All right, what if I do number 16 and 20 here to finish it off? Okay, number 16. A 2,000-liter tank contains 550 liters of water is being filled with the water at the rate of 75 liters per minute from a full 1,600-liter tank. So there's two tanks. And go from there. How long will it be before the two tanks have the same amount of water? So I really want to take out one of our classmates here, thanks Hunter here, really get a description of what actually is happening. So right now, there's two tanks, right? One of the tanks has this much, and the other tank has this much amount of water. And what's happening every time? So it's starting at this, and what's happening is this is basically gaining, what is it? 75. So every time it's going plus 75, plus 75, plus 75. We're increasing water here. And where's this water coming from? It's actually coming from over here. So here, every time it's going minus 75, minus 75, minus 75. And basically, the idea is saying is how long is it going to take before these two containers get the same amount? And you get it here. So Hunter did a really nice job of showing like that he understood what the problem was happening and was able to get the answer with this simple chart. Now, how would we want to actually write an equation to do the same thing? Well, it's pretty easy. You always want to start with, well, what do you have? Well, in one tank, this could be like tank 1 here, and this could be like tank 2. And we're saying, when are they the same, right? So tank 1, you have how much? Well, you're starting off with 550 gallons over here, right? And over here, you're starting off with 1,600 gallons. And what's happening every time? So every time, every minute, it increases by 75. So basically, for every minute, it increases by 75. So 1 minute, you had 175. For 2 minutes, you had 275s. So this allows us to say what's happening every minute. So here we're adding, right? It's gain increasing. And over here, we're actually losing. So this would actually be just minus 75. So every time it goes minus down, 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 down. So we just want to say, when are these going to be the same? And so, again, here's your equation. And all you've got to do, just cancel them both out. Start with the smaller coefficient. To get rid of that, you just add 75m. You're like, oh, they're going to cancel out. But actually, they don't. These cancel out. Woohoo! Those don't. You get 150m. And that's 1,600. That's still 550 over there. And so from here, just want to get that little m by itself. So we want to subtract 550 first. And that'll be what? 1,050 equals 150m. Just divide by 150. How many 150s go into that? And I believe it will be, I want to say 7 times. Yeah, I think it is. How about that? M equals 7. So again, so there it is. And again, same thing with Hunter. Hunter found out it took us like 1, 2, 3, 4, 5, 6, 7. So this really shows you minute by minute what happens. And this is almost like a shortcut of like getting right to the answer, which you can work, which is helpful if you know how to set everything up. All right, and let's talk about number 20 here. Number 20. Is it possible for 4 consecutive even numbers to have a sum that is 10 more than blah, the smaller of the two numbers? Okay, so again, first things first, let's identify our variables. So we've got our first consecutive number, which is just n. Our next consecutive number, even number, is going to be n plus 2, n plus 4, and n plus 6, right? So you got your smallest one, small, you got your largest one, large, and then you got like your middle ones here, middle. Okay, and so what is it saying? Is it possible for 4 consecutive even numbers to have a sum that is 10 more than the sum of the smallest 2? Well, the sum of those would just be, well, you add them all up, right? So it'd be like n plus 2, you can put parentheses around it, plus n plus 4, plus n plus 6, right? So the sum, we're saying, is it possible for all of this to be 10 more than, so again, plus more 10 more than what? The sum of the smaller two numbers. So again, what are the small two numbers? So it's going to be, this is a smaller number, so those two. So we're saying, is all of them can be the same as 10 more than 2 of those? And at first, like, that can't work out, right? But again, let's just do the equation and go from there. So there's our crazy stuff. So we just got to simplify this. So we simplify over here, n, 4n, 2, 4, 6 is going to be 12. And then over here, n is just going to be 2n, and then we got 2 and 10, which is also going to be 12. And you're like, aha, cancel. So something crazy is going to happen, but it's not really. So subtract 12, yeah, they just cancel out. And you end up with 4n equals 2n. And at this point, you're like, oh, it's got to be identity, or maybe it's got to be no solutions, but let's just think this out. The next step is subtract the smaller number. Subtract the smaller number, and you end up with 2n equals 0. And you're like, oh, something cancel out? Yeah, but the n is still there. So again, what will you do? Get n by itself. Divide by 2, and n equals 0. And you're like, oh, what does this mean? Well, that's actually the answer. It means n is actually 0. So it's like, okay, so what does that mean? So, well, it's here. That means n 0, right? And if n is 0, then the next number is 2, and the next number is 4, next number is 6. So let's see here. If this is the first number is 0, and this one's 2, and this is 4, and this is 6, let's see if this thing's actually true. So it says, can the sum of these four numbers, 0 plus 2 plus 4 plus 6, be 10 more than the sum of the first two, like 0 and 2? So what if is that? What's 2 plus 4 plus 6? Well, that's just 12. And then what's 0 plus 2 plus 10? That's also 12. So yes, so in reality, this can work, and this is how it works. So there's one way of doing it. Tricky, but okay. Thanks.